Part H is the trickiest of all and will require us to put together what we remember about probability properties as well as the features of the standard normal distribution. So we need to find the probability that z is less than some unknown boundary, let's call it z1, given z is also greater than 0, and this probability is equal to 0.853. I want to remind you what this given means. It's the conditional probability, and if I go back to the probability formulas, I'll recall that probability of event A given B is equal to probability of A and B, intersection B, over probability of B. I'm going to rewrite this given statement using this formula. Again, recall, I want to call this unknown boundary z sub 1 to make it easy to track who's who. So probability of z less than z sub 1 given z is greater than 0, according to this formula, should look like this. Probability of z being less than z sub 1 and z is greater than 0. I use the intersection symbol, upside down letter U, over probability of the condition, in this case, probability of z is greater than 0. Of course, it's still equal to the given number of 0.853. What is the probability of z greater than 0? 0 is exactly halfway through this curve, so area to the right of that value should be 50% or 0.5. So I replace p of z being greater than 0 by 0.5. Using basic principles of solving equations in algebra, I'm gonna think of this number on the right-hand side of the equation as 0.853 over 1 to create a fraction. Now I can use the cross multiplication principle to solve this equation for this unknown expression, and it means I'm gonna multiply across 0.5 by 0.853. As a result, I get probability of z less than z1 and z greater than 0 equal to the product of 0.4265. Please notice it means that when I draw this curve and I get this interval z less than z sub 1, it's this unknown point z that has a lot of area to its left. I shaded that area in green. And at the same time, z greater than 0. So 0 is here. I shade everything to the right side of it in red. This intersection will be this chunk where both of these intervals are intersecting. This amount is 0.4265. If this chunk, this intersection, is 0.4265, I can add this quantity with the 50% of area to the left of 0, and it gives me together the amount of area to the left of z sub 1 to be 0.9265. All I need to do now is find this unknown score, z sub 1, with the help of the area to its left using technology. The Art of Stat app tells me that the point that has 92.65% of data to its left under the standard normal curve with the mean of 0 and standard deviation of 1 must be 1.45.